Good morning. So last time we started by link state routing protocols, and we said that the main algorithm or the main protocol under link state routing protocol is shortest path first, or the Dijkstra algorithm, or the Dijkstra shortest path first. And we studied how we can calculate the best path if we have this weighted graph, the Dijkstra or shortest path first construct or generate the weighted graph like this by exchanging link state updates between different routers and building a link state database. We can construct or generate this weighted graph at each router, and then using the Dijkstra algorithm or shortest path first, we can select the best path or a minimum cost path to all destinations, and this minimum path will be put in the routing table. And we see we discussed how we can calculate the shortest path to, for example, for router one, shortest how we can generate the shortest path first tree from router one to all other destinations. And we discussed different link state protocol packet types like hello protocol and hello packets, discover neighbors. And the first step, we discussed the different steps of a link state routing protocol. The first step can sending hello packets to the neighbor to discover a neighbor and make sure that all routers are still alive. Then we build link state packets or link state packet updates. We exchange a link state packet between different routers to exchange a link information or a link state. Then from this link state packet, we flood this packet to all routers, mean that we relay each router receive a link state packet, will relay this packet or forward this packet to all other nodes. So we use flooding link state packets to all neighbors and to all nodes in the network to generate a global view of the network. After this flooding, we construct a link state database. From this link state database, we can run the Dijkstra algorithm to calculate or to build the shortest path first tree. And from this tree, we can generate a routing table with the shortest path to all destinations. These are shortest path first tree. We construct shortest path first tree. Then we run the algorithm to construct a routing table. So these five main steps, are the main steps of link state routing protocols and how we can start it from hello packets until we construct a link state routing table and shortest path first tree. Okay, so these are the main steps of link state routing protocol. We finished at this slide by discussing a requirement for using link state routing protocols, and we said that for the memory requirement, it uses more memory. Why? Because of building a link state database. This database contains a lot of information, contain global view of the network, or contain all information about all nodes and all links of the network. So it uses more memory to construct this link state database. Also, it uses more CPU to process link state updates and the flooding of link state packets and building link state database and generate from this database generate routing tables. But all these steps need or consume more CPU. From the bandwidth requirement, it consumes lots of bandwidth at the beginning, just at the beginning to exchange link state updates and make flooding of link state updates. But this flooding, because each packet will be forwarded to all other nodes, but this flooding will consume a lot of bandwidth. But this initially at the beginning. Okay. Any question? Okay. Then today we'll start by open short specific الباكت بقى السبيسيفيك باكت كونتنت او المسج of الاوبن shortest path first المسج content. ف first we need to in this message we need to define the packet type. We have to add one field for identifying the packet type, and there exist 5 types of packets can be exchanged under the open shortest path protocol. But first we need to identify the packet ID or packet type. Then we add the packet header. This packet header contain a router ID, area ID, and the open short space first packet type. فwe need to add the header. Then the IP header is يعني usual in all packets, the source IP address with destination IP address with protocol type and so on. So this is the main fields that will include in the open short space first message. This is the most important part, the open short space first packet types. And there will be one question here in the final. دي ميزة بقى اللي بيحضر بقى بيعرف ايه اللي هيجي واللي مش هيجي. فthere are 5 types of open short space first packet types. Low packet, طبعا each packet you should know the packet type and the function of this packet or the description of this packet or why we use this packet. A hello packet to discover a neighbor and build the adjacency between them. This is easy. Hello packet to discover neighbors. Then database description to check for database synchronization between routers. Because as we said, we exchange all information between all routers and we build a database. So this database should be synchronized at all routers. All routers should know the same information. The database should be the same at all routers. We send this database description packet to check if our database is the same, mean that we reach the convergence. We have all information in all databases. But if some databases have less information, so we can exchange more updates to maintain these changes or to make sure that the synchronization between database or all databases are the same. But database description to check for database synchronization between different routers because we need database to be the same at all routers. Then link state request. This is to request a specific link state record. If I need to ask about specific link and I need to collect information about specific link, so I send link state request. So I request a specific link state information or specific link state record from router to router. So for example, from router 1 can send specific request to router 2, please tell me more information about this link. A link state request to request or ask about specific link state information from router to router. Then the link state updates, this send to exchange or to be used for link state records. This is the main packet we use and we make flooding for this packet to exchange a link state information. At the beginning after hello, we exchange a link state updates packets to exchange a link information and building a database. But this link state updates are used or sent to request links to يعني exchange a link state information or link state updates. Then the fifth packet, the link state acknowledgement is to acknowledgement the receiver of this packet. So if I send request, I will reply with acknowledgement. If I send some database description, I will reply with acknowledgement. So this is just acknowledgement packet to make sure that I receive the packet correctly. That is to acknowledge the other type of the packets. Okay, so these are the main types of packet for open short space first. Again, for hello protocol, same as we discussed in distance vector protocol. Here we repeat for open short space first. Hello protocol, we send hello packets. These hello packets are used to discover neighbors and establish adjacency between different routers. Advertise guidance on which routers must agree to become neighbors. So we agree using this hello packet who are my neighbors and who will be my neighbors. And we use by multiple access. In case of multi-access network, we use this hello packets to select a designated router or a backup designated router. In multi-access network, this is a special type of the network. We select one designated router, which will be the central router, يعني our main router. This is just بس يعني just new يعني new updates to just in يعني facilitate link state flooding. Instead of all routers send all other nodes and all other nodes forward to all other nodes, this in this special case in multi-access network, we send all routers send to the designated router, and this designated router receive the updates and broadcast these updates to all routers. So instead of sending from one router to another, all routers send to a designated router, and this designated router will forward back the updates to all other routers. This is the rule of designated router. The backup designated router, this will be backup router. Is the designated router shut down or become down, the backup will replace this designated router. We use the hello bucket to select who will be the designated router or who will be the backup designated router. But these are the main functions of the hello protocol. Yes. Okay. المين content في الهلو bucket will include a router ID, the ID of the routers that will transmit this packet. Interval, we send this packet every 30 seconds for non-broadcast multiple access technique network, and this packet are sent every 10 seconds on multi-access network or point-to-point serial link. It can be sent every 10 seconds in multi-access network, or usually it's sent every 30 seconds in case of non-broadcast multi-access network. And as we said برضو in the distance vector, once we have a hello interval, because hello packets sent periodically, so we send this hello packet, for example here every 30 seconds I will send this hello packet. طيب did interval or it doesn't time out, here we name it did interval. This is 4 times the hello interval, and if I send 4 times hello packet without receiving reply, it means that the neighbor is down. So I will consider this neighbor is down if I wait for the dead interval or for 4 times the hello interval without receiving any reply from this neighbor router. I will consider it down. For dead interval, the time I should wait before consider my neighbor router down. Okay? Again, hello packet is used to select designated router and a backup designated router. Definition of designated router is very important also. Designated router is responsible for updating all other open short space first router, because it will be the main routers. This designated router will be the main router. All other routers, that means router 1, router 2, router 3, all other routers will send the updates to the designated router, and the designated router will then broadcast back all updates to all nodes. So instead of sending these updates back and forth and broadcast the updates, we select one designated router and we send the updates. All updates sent to the designated router, then designated router will broadcast back all the updates. So designated router will be responsible for updating all other routers. Will be the main routers that collected information and updated all other routers. The backup designated router it will take over the responsibility of its designated router if it's filled over its or if it's become down. So it's just a backup. If the designated router fail or become down, it will replace or it will take over the responsibility of its designated router. يعني here 2 questions في الفاينل. Designated router will type of الopen short space first. يعني الباكيتس types and the rule or function of each packet. Okay. Second more important packet is link state updates. So the purpose of link state packet update or link state update packet used to deliver a link state advertisement. And what's link state advertisement? This advertisement contains information about the neighbors and the path cost. So each link state update packet can contain multiple advertisements. So multiple information about multiple links. So each information or each advertisement, we name it link state advertisement, and we can combine multiple link state information into one link state packet. And the main purpose is to exchange link state information between different routers. But this is for link state updates bucket. Then open shortest path first algorithm بقى. We build and maintain link state database containing link state advertisement received from all routers. فالمين ستيبس طبعا after exchanging يعني first we exchange hello buckets between node we discover adjacency and then hello buckets and we select designated routers and we exchange this hello bucket periodically between different routers to make sure that all routers are working fine. Then we exchange a link state updates or a link state advertisement between different routers. From these updates we build a link state database. خلاص link state database contain all information about all routers and all nodes in the network. Once we build this link state database we run open shortest path first algorithm بقى اللي هو mainly يبقى digester as an example. By running this algorithm we extract from this database the shortest path first tree. So starting from specific router that runs this algorithm we define shortest path to all other destinations. This can can be يعني presented can be represented in a shortest path first tree. Then from this tree we can generate a routing table بقى. And this tree contain the best path or the least cost path from the router to all other destination. This information will be collected and put in the routing table. But these are يعني and this figure summarize all and the main steps of the open shortest path first protocol. Algorithm, the main function of the open shortest path algorithm is to generate the shortest path first tree from a database. After building a database and building database طبعا from link state updates. After building a database, I generate a shortest path first tree. This is a function of an open shortest path first algorithm. You will find most of the material of this chapter like this definition and function, definition and function. Then information after building and maintaining and updating a link state database, we use the information in the database is utilized by the Dijkstra shortest path algorithm to build or create a shortest path first tree. Finally, from this shortest path first tree, we build a routing table. These are the main steps of an open shortest path first algorithm. Building a database, generate shortest path first tree, then run digester algorithm to build a routing table. Any question? طبعا how to بقى run open shortest path first we use command router open shortest path first and specify process ID, and this process ID is local ID just to identify the process that's running that or process that use this protocol and what routers that are using this protocol. This means it doesn't have to match the other open shortest path first router because I can run different process from this protocol. To run or to enable open source path first protocol in a specific router, we just run command router open source path first and identify the process ID. For example, router open source path 1, router open source path first 2, and so on. So I identify or enable or start this protocol and identify just the process ID for this protocol to be run on group of routers. Okay. Here important بقى open source path first metric. What is the metrics that we used for open source path first? As we used every protocol using different type of metric to select the best path. For example, a rep can be considered which metric for rep can be considered number of hubs. Other routers can be considered bandwidth with delay, with reliability, with load as optional. Here in open source path first, consider the cost as a metric to determine the best route. والبيست route طبعا will have the minimum cost or the lowest cost. طيب what is the cost بقى؟ Cost is a function of the bandwidth of a specific interface. فالمين parameter here we have a specific interface or a specific link I will calculate the cost as a function of the bandwidth. فاللينك with large bandwidth it mean it will have less or high cost. Hmm. And I need to select the route with the lowest cost. فالcost function of the bandwidth will be proportional to the bandwidth ولا inversely proportional to the bandwidth? Inverse exactly. And it's better to have more bandwidth. فif specific route have large bandwidth, it means it's better for me to select it. That means the cost is low. The cost is calculated as 10 to the power 8 divided by the bandwidth. And 10 to the power 8, this we name it default our reference bandwidth اللي هي 100 megabit per second. 10 to the power 8 اللي هي 100 mega. But this is the default or reference bandwidth or maximum bandwidth. يعني when they identify this protocol, this can the maximum bandwidth available at this time. But this is considered as the reference matrix, as the reference bandwidth. And to calculate the cost of each link, اللي هو you see, this cost you see it in the first example here. This costs, and we said how to calculate the best path with minimum cost. But this cost is calculated or coming from the bandwidth of this link. This cost is generated from this formula, and the cost is calculated as 10 to the power 8 divided by the bandwidth of the link. Okay. For example, for fast Ethernet, the bandwidth is 10 megabit per second, the cost will be 1. If, for example, for Ethernet, bandwidth is 10 megabit per second, when we divide 10 to the power 8 by the bandwidth, 10 megabit per second, I will find the cost 10, and so on. So from the bandwidth of specific link, I can calculate the cost. Then after calculating the cost, I will select the best path with lowest cost. وطبعا الcost is accumulative. From link to link, if I need to define the best path from the source to the destination, I accumulate the cost and select the path with the minimum cost. The cost is accumulative. Okay. The cost of an open source bus first is accumulated value from one router to the next. Okay, we identify the cost as 10 to the power 8 divided by the bandwidth. Then we accumulate the cost from the source destination, and for all possible paths, then select the path with the minimum cost. Here, usually the actual speed of the link is different from the default bandwidth. يعني usually the speed is not actually exactly the value of the bandwidth. At some time, the speed of the link may I have some congestion or something, I have large bandwidth, but the speed is still low due to some مثلا high load on this link or due to some congestion on this link. The speed of the link is different from the bandwidth. But for this algorithm to run well and select the best path and correctly, this routing table has selected best path as the lowest as the highest bandwidth. Should the bandwidth reflect the actual speed link. But for this algorithm to work well, the bandwidth should be يعني function or should reflect the actual speed of the link. Because if the bandwidth, and for example, if this link has high bandwidth but very low speed, mean that this algorithm will select this link and select it based on the bandwidth only. I don't care about the reliability or a load or other parameters. فإف الباندويث doesn't reflect the actual speed of the link, it means that this algorithm will select not the best path because it selected the best path as a function of the bandwidth only. But for this algorithm or for this protocol to run well, the actual bandwidth of the link should reflect the actual speed of the link. And if the bandwidth is high, the speed should be high. If the bandwidth is low, the speed should be low. فالسبيد not the same value, يعني the value of the speed not the same as the bandwidth, but at least the value of the bandwidth should reflect the speed of the link. Why? Because I will select and build the routing table as a function of the best path with minimum cost, which means with the highest bandwidth. But the bandwidth should reflect the actual speed of the link. And to know طبعا the actual bandwidth of the link, we run command show interface. So from show interface, I can know what is the bandwidth of this link. For example, R1, if I need to know the bandwidth of this link, I run show interface. So I collect the information about this link. If I need to collect or to know the bandwidth of the other interface, I will run show interface. For this interface, I will collect the bandwidth of this interface. From the bandwidth, I can calculate the cost and then select the path with best cost. Okay. Any question؟ any question في الراوتر في الراوتنج كله؟ هتذاكر اصلا الراوتنج؟ ده 90 سلايد. هذا كروم في اسبوع؟